Okay, today starts chapter 6, and we're going to be talking about polynomials and quadratic functions, and this is what we will finish out the year with. So first off, we're going to do 6.1a, so half of this section, and we're going to talk about operations with polynomials. Our objectives will be to talk about the vocabulary. Hopefully you will learn that if you don't already know it, adding and subtracting, and then multiplying, part of multiplying. So to begin with, know that a polynomial is a single term or the sum of two or more terms containing variables with whole number exponents. So an example of a polynomial, it's a single term. So 3 is an example of a polynomial. 4x squared is a single term that's a polynomial. You could have just x, or you could have the sum, and so 5 plus x cubed. Notice that my exponents are whole numbers, and then I have single terms or the sum, and that of course could be minus. We also have polynomial functions that we'll get into later, and that's the expression that defines the function is a polynomial. Okay, so the next thing you need to be aware of and you need to know is the degree of a polynomial, and the degree of the polynomial is that exponent. So we say ax to the n has degree n, and if it's a non-zero constant, then it's 0. So when you look at this polynomial, this term has a degree of 3. This one has a degree of 2. This one has a degree of 1. And think about this one doesn't have a variable, so no variable means it's going to be a degree of 0. Okay, um, so if we look at this, the other thing you got to think of, that's each term. So when you talk about each term, then the degree of the polynomial that has many terms is the degree of its highest ordered term. So if I give you this polynomial, this has a degree 3, 2, 1, and 0. So the degree of the polynomial is 3. It's third degree or degree 3. This one here, again, this term is 4, 1, 0. So the degree of the whole polynomial is 4 because it's the degree of the highest term. Okay, we talk about the degree. We also classify polynomials according to how many terms it has. So it is a monomial. Hopefully you know mono means one. So it's a monomial if the polynomial has one term. Binomial if it has two terms. Trinomial if it has three terms. So if you have this example here, it is a certain degree. Well, we just talked about that. The degree of the highest term is 4, so it's a fourth degree. And how many terms does it have? It has 3 terms, and so it is a fourth degree trinomial. So to add polynomials, we have to combine what we call like terms. And the like terms are terms that contain exactly the same variables to the same powers. So if you look at 4x squared plus 6x squared, then these two terms have exactly the same powers, exactly the same variables. And so when you combine them, you want to think about just combining your coefficients. So they write it like this. So you're thinking of 4 plus 6. The x squared is not going to change, and my answer is going to be 10x squared. Okay, so look at some of the problems you'll have to do. They're a little more involved. But one of the things that you got to remember is whatever sign comes in front of the term, that's attached to the number. So the first thing you do when you're adding is you need to remove the parentheses. If it's a plus in front of here, I didn't need the parentheses to begin with. And what I did was I kind of color coded it so you could see already what our like terms are. So to combine my like terms, I'm going to get my x cubes together. So negative 7 plus 19 is 12x cubed. So I combine the numbers and do not change the variables. Next, I have my x squared. So I have 6x squared minus 11x squared, and that's minus 5x squared. Then I have minus 11x plus 7x. That, of course, is minus 4x. And then I have 13 minus 17, which is negative 4. So the answer to adding this is 12x cubed minus 5x squared minus 4x minus 4. So I wanted to do another example to show you that, again, we're adding, and we remove these parentheses. Again, I color coded to make it easier to see, but when we go through and combine like terms, sometimes instead of drawing the arrows, we just go through and underline, especially when we have lots of them. So I underline negative 2x cubed once, and then I go find another x cubed and I underline both of them one time, and I combine them. Negative 2 plus 5 is positive 3x cubed. Then I go to my next term, which is squared, and go find any other squares and underline them both twice. 8x squared plus 4x squared is 12x squared. Then I go to my next term, that's an x, and I'm going to find the other x. This is negative 10 minus 8, and that's minus 18x. And then sometimes that gets a little lengthy, so I go to a little squiggly, and 2 minus 7 is minus 5. Okay, if you're subtracting polynomials, you've got to remember that when you first you need to remove those parentheses, but when you do that, you have to remember to distribute that negative sign. And what that's going to do, first off, the first polynomial doesn't change, 8x squared minus 10x plus 2. But when you distribute a negative, as we have seen many times in the past, it changes the sign of every term inside the parentheses. So if this is positive because there's not a negative sign in front of it, it is now going to be negative. This is negative 6x. It will now be positive 6x. And minus 7 will be positive 7 because that's the effect of distributing your negative. So we go combine like terms. I underline my x squared once and go find the other x squared terms. Underline both of them once. 8x squared minus 5x squared is 3x squared. Go to the next term and underline it twice, x and x, so I have minus 10 plus 6, and that's minus 4x. And then I squiggly my constant, which is plus 2 plus 7, which of course is plus 9. So if you have any trouble with that, IXL has a great activity to help you recognize those like terms, and I'll be happy to help you navigate through that if it's difficult. But this is a very important concept, and the earlier you get it down, the easier life's going to be for you. Okay, the last thing we got to talk about is multiplying, and actually the first part of multiplying. And we have the product of two monomials, and when you do that, you just need to remember this is all multiplication. So I'm going to multiply my numbers, negative 8 and 5, and then I'm going to multiply my variables. And when you multiply variables, if you have the same base, you add the exponents. So this becomes negative 4x to the ninth. So if I give you an example, 3x times the quantity of 2x squared minus 5x plus 7. Remember, we have to distribute this 3x to every term. So I did that and highlight and put it in red so you could see 3x times the first term. Notice where the minus sign. You could put plus and then minus 5 if you wanted to, but it's just as easy to keep the negative there. 3x and 5x and then plus 3x and 7. So I'm multiplying my numbers, 3 times 2, adding my exponents, multiplying the numbers, adding the exponents, multiplying the numbers, and I end up with just one variable. So when you simplify, this is 6x cubed minus 15x squared plus 21x. Okay, one last example. If you have to multiply a binomial and a trinomial, okay, sometimes people get lost in all that they have to keep up with. So I wanted to get you familiar with a vertical method. Take the longer one, put it on top, and underneath it, write the shorter one. So we have the trinomial and the binomial. This kind of helps you keep up with your distribution. I have to multiply 3 times all of those, and I have to multiply 2 times all of those. So I'm going to do it like our standard multiplication algorithm, and I'm going to start with 3 times 5 is 15. 3 times 4x is 12x. 3 times x squared is 3x squared. Then I'm going to go to the next one. 2x times 5. That's 10x, but I'm not going to put it here because that doesn't have an x in it. I'm going to put it underneath my 12x, because now I have my like terms lined up. 2x times 4x is 8x squared, and 2x times x squared is x cubed. So if you notice by doing this, we have our like terms lined up, and we just add. 15 plus nothing is 15. 12x plus 10x is 22x. 3x squared plus 8x squared is 11x squared, and there's nothing to add to the 2x cubed, so that's what we have. So the next lesson we will talk about two binomials and special cases. But if you have any questions with this or need help with IXL, then please come see me.